So last time what we were talking about? We were talking about the timers, right? There are two timers, timer 0 and timer 1. Okay. So the timers of your 8051 microcontroller operate in different modes like mode 0, mode 1, mode 2 and mode 3. So for selecting the modes of your timer, so for selecting the modes of your timer, so for selecting the modes of your timer 8051, this register timer mode control register is okay. So this TMOD register or timer mode control register is a 8-bit register. As you can see, this register, it is an 8-bit register. So there are actually, this register is actually divided into two parts. The bit 0 to 3 is used for the mode selection of timer 0. Okay. And the bit 4 to 7 is used for the mode selection of timer 1. Okay. So there are two timers. The first half, the lower half of this TMOD register is used for timer 0 control, and the upper half, the upper 4 bits are used for timer 1 control. As you can see, the bits in this register are M0, M1, C by T and gate. Okay. So your timer, okay, as I already told you, the timer is nothing but it is used for generating the, for counting the time or generating the time signal. Okay, so what happens? The timer of your 8051, what it does is it actually uses a 16-bit register. Okay, a 16-bit register your timer actually uses. So last class I explained about it. Once again I will briefly explain. Okay. So your 8051 microcontroller actually uses a 16-bit timer register. Okay. So this 16-bit timer register is itself divided into two parts. Okay. The lower byte, the lower byte or the lower 8-bit is called as TL, and the upper 8-bit or upper byte is called as TH. Okay. TH. Okay. If it is timer 0, then it will be TL0 and TH0. And suppose instead of that, if it is timer 1, if it is timer 1, instead of this TL0 and TL1, it will be okay. Instead of this TL0 and TH0, for timer 1, it will be TL1 and TH1. Okay. So basically there are two timers, timer 0 and timer 1. There are two timers here in your 8051 microcontroller. So they use 16-bit of register. Okay. The lower half of that 16-bit register is TL and upper half is called as TH. If it is timer 0, it is TL0 and TH0. If it is for the timer 1, then it is TL1 and TH1. Okay. So your timer actually works in four modes. Okay. Your timer, your 8051 timer actually works in four modes. That is mode 0, mode 1, mode 2 and mode 3. I told you about this also in the last class. Okay. So again, once again, briefly I will explain you, no problem. Okay. So your timer of 8051 microcontroller, they work in four modes. That is mode 0, mode 1, mode 2, and mode 3. These are the four modes of your 8051 microcontroller timers in which they work. Okay. In mode 0, what happens is, as I told you, your timers use a 16-bit register. What it does, it uses a 16-bit register for generating the timing signal. Okay, how it generates, how to generate the time signal, there is one separate section for it. Okay, at that time we will learn about it in detail, how to generate the timing signal, how to calculate the time. It is just like a stopwatch timer. For example, for some certain thing you want to set a time that the microcontroller should perform certain function after 1 minute. Okay, so you can start the timer after that 1 minute elapses, or after that 1 minute completes, your timer says 1 minute has completed to your microcontroller, and then whatever function it needs to perform at that, the microcontroller will perform. Okay, that kind of timing signals are generated in the 8051 microcontroller timer. So in detail, how to generate that 1 minute time duration timing signal, everything about the programming and everything, you will learn later. There is separate section for it. Okay, in this first unit, just you need to know about the four modes of your timer. Okay, as I told you, it uses a 16-bit, your 8051 timers uses a 16-bit, okay, 16-bit register. Okay, it uses a 16-bit register. What happens in the mode 0? What happens in the mode 0 is, out of this 16-bit, only 13-bit of it are used. Okay, only 13-bit are used. But in mode 1, all 16 bits are used. Okay, all 16 bits are used. Okay, so in mode 2, what happens is, only it function as a 8-bit register. Okay, it functions as a 8-bit. Out of that 16-bit, only 8 bits are used for generating the time. Okay, in mode 3, what happens is, consider this is your register. Consider this is your 16-bit register. Okay, so as I told you, there are two parts in this, the lower byte and upper byte. This is 8-bit, and this is also 8-bit. Okay, so what happens in the mode 3? What happens in the mode 3 is, there are actually in the 16-bit, both the lower 8-bit and upper 8-bit, they are used separately. Okay, so the lower 8 bits function as 8-bit timer, and upper 8-bit are also functioning as a separate timer. So in mode 3, what happens is, actually two 8-bit timers are running. Okay, two 8-bit timers are running. In mode 2, only one 8-bit timer is running. Okay, but in mode 3, what is happening is, two 8-bit timers are running, lower 8-bit and upper 8-bit. Okay, so generally I will explain you how actually the timer in the 8051 is working. Okay, so as I told you, it uses a 16-bit register, right? It uses a 16-bit register. So since it uses a 16-bit register, so what is the maximum value that you can store in this? What is the maximum value that you can store in a 16-bit register? It is 65,000. Okay, it is 65,535. This is the maximum value you can load in a 16-bit register. So how to for example, you want to generate a 4 microsecond of delay. Okay, suppose you want to set a timer for 4 microsecond. That means after 4 microsecond, you want to perform a certain event. Okay, maybe after 4 microsecond you want to turn on an LED connected to the microcontroller. So what this microcontroller, how this timer will function for that? Out of the 65,535, whatever number of microsecond you want to generate, you can subtract it, so it will become 65,531. So this is the value 65,535. This is what is loaded in your 16-bit timer. Okay, this value, whatever microseconds you want to generate, that you need to subtract from the maximum value. Okay, 65,535 में से 4 को subtract करना, because you want to generate a 4 microsecond timer or 4 microsecond delay. So you will get how much, what value you will get? 65,531 you will get. So you just need to store that value. Okay, you just need to store that value in your 16-bit register. So this is the value you loaded. Okay, once you load this value 65,531, once you load this value, then microcontroller, what it does is it starts the timer. It, what it does, it starts the timer. Okay, once the timer starts, what happens in this register is it starts to increment this register. It starts to increment this register value. So what it will do first? So like this it will increment. So what it will do? It will become 65,532. Then it will become 65,533. Then it will become 65,534. Then 65,535. Okay. So this is called as incrementing. Incrementing का मतलब क्या होता है? जो भी आपका रजिस्टर का वैल्यू आप शुरू में लोड करते हैं, उसको एक एक वैल्यू से ऐड करना, +1 करना, उसको बोलते हैं इंक्रीमेंट करना. ओके, इंक्रीमेंट का मतलब क्या है? जो भी आपका रजिस्टर का वैल्यू है, जो इनिशियली आप लोड किए हैं, यहाँ पे इनिशियली क्या लोड किए थे आप? 65,531 लोड किए थे. टाइमर स्टार्ट होते ही आपका प्रोसेस क्या स्टार्ट हो जाता है कि वो टाइमर को इंक्रीमेंट करना शुरू कर देता है. ओके, लेकिन इंपॉर्टेंट बात यह है कि आपका जो रजिस्टर का कंटेंट है, उस रजिस्टर के कंटेंट को एवरी 1 माइक्रोसेकंड, ओके, एवरी 1 माइक्रोसेकंड के बाद इंक्रीमेंट करता है. ओके, एवरी, द माइक्रो कंट्रोलर क्या करता है? ये जो रजिस्टर है उसको एवरी 1 माइक्रो सेकंड के बाद इंक्रीमेंट करता है. ओके, सो देखो 31 स्टार्टिंग में आप लोड किए, यू लोडेड वैल्यू ऑफ 31 इन दिस. ओके, देन आफ्टर एवरी 1 माइक्रो सेकंड स्टार्ट्स टू इंक्रीमेंट दिस रजिस्टर. From 31 it becomes 32, then 33, then 34, then 35, like this. Okay, so totally how much delay you generated? You generated 4 microsecond delay, no? Here 4 microsecond delay, right? After 4 microsecond it reaches the maximum value of 65,535. Okay, it reaches your register, 16-bit register reaches its maximum value of 65,535 after 4 microsecond. जैसे ही आपका रजिस्टर इसकी मैक्सिमम वैल्यू को पहुंच जाता है ना, तो टाइमर को यह समझ में आता है कि जो भी टाइमर सेट किया गया है, टाइमर जो भी सेट किया गया है वो कंप्लीट हो चुका है. यानी कि यहाँ पे हम लोग क्या किए थे? 4 माइक्रोसेकंड का टाइमर सेट किए थे, राइट? उस क्योंकि 65,535 में से 4 को सब्ट्रैक्ट किए, 65,535 आया, वो लोड किए, लोड करने के बाद टाइमर स्टार्ट हुआ. टाइमर स्टार्ट होने के बाद क्या होगा? 16-बिट रजिस्टर जो आपका है वो इंक्रीमेंट होना शुरू हुआ, 31 से 32, 33, 34, 35, इस तरह से 4 माइक्रोसेकंड का डिले जनरेट हुआ, राइट? तो ये जो 65,535 का मैक्सिमम वैल्यू जैसे ही पहुंच जाता है, तो माइक्रो कंट्रोलर को ये पता चल जाता है कि जो भी टाइम आप सेट किए थे वो फिनिश हो चुका है. अब उसके हिसाब से जो भी आपको एक्शन लेना है माइक्रो कंट्रोलर को, जैसे कि एलईडी अगर जनरेट करना है, वो जो भी बर्न करना है, जो भी करना है, वो माइक्रो कंट्रोलर वो एक्शन परफॉर्म करेगा. सो बेसिकली हाउ द माइक्रो कंट्रोलर टाइमर इज वर्किंग. यस, are you getting this point? how the microcontroller timer is actually generating the timing signal. Here we generated the 4 microsecond timing signal. Okay, कुछ नहीं करना है, जितने भी माइक्रोसेकंड का जनरेट करना है उस मैक्सिमम वैल्यू में से सब्ट्रैक्ट करना है, जो भी वैल्यू आपको मिलता है उसको वो रजिस्टर में से लोड करके टाइमर स्टार्ट कर देना है. टाइमर स्टार्ट होने के बाद ऑटोमेटिकली एवरी 1 माइक्रोसेकंड इंक्रीमेंट होगा. तो ऑब्वियसली यहाँ पे कितने बार इंक्रीमेंट होगा, मैक्सिमम वैल्यू को रीच होने के लिए 65,535 मैक्सिमम वैल्यू है, यू लोडेड 65,531. ओके, तो 4 माइक्रोसेकंड जनरेट करने के लिए 1 by 1 इंक्रीमेंट होगा रजिस्टर. इट विल रीच 65,535 आफ्टर 4 microsecond. That is natural. Okay, so once it reaches whatever value you load, from that value only it will start to increment the 16-bit register. Okay, instead of 65,531, if you load 65,530, from that value it will start to increment, and it can increment up to a maximum value of 65,535, because 16-bit में इससे ज़्यादा value load नहीं कर सकते. Your 16-bit register cannot hold the value greater than 65,535. So whatever value you load, whatever the value lower than 65,535 you load in your 16-bit register, from that value only it will start to increment the register. Okay, so जितने बार increment होगा into 1 microsecond, that is the time generated by your timer. Okay, तो वो वैल्यू कैसा निकालना, सिंपली सब्ट्रैक्ट कर दो मैक्सिमम वैल्यू में से, यू विल गेट वट एवर द वैल्यू यू वांट टू लोड. ओके, दैट इज वेरी सिंपल. ओके, दिस इज हाउ योर टाइमर फंक्शंस फॉर जनरेटिंग द टाइमिंग. ओके, इट इज जस्ट लाइक ए स्टॉप वॉच. ओके, you set some timing events. Once the maximum time is reached, your timer क्या करता है, ये your microcontroller को interrupt करता है. क्या करता है टाइमर, क्या करता है माइक्रो कंट्रोलर को इंटरप्ट करता है. जो भी आप टाइम सेट किए वो टाइम सेट रीच हो गया है, आप जो भी एक्शन लेना है यू कैन टेक दैट एक्शन. ओके, सो दिस इज हाउ बेसिकली योर टाइमर फंक्शंस. सो योर टाइमर फंक्शंस बेसिकली इन how many modes? 4 modes, that is mode 0, mode 1, mode 2 and mode 3. okay, mode 0 में क्या होता है, out of this 16 bit whatever you are using for this register, I told you it is the timer of the 8051 uses 16 bit register. Okay, out of this 16 bit only 13 bits are used. Okay, only 13 bits are used. In mode 1 what happens, all the 16 bits are used. Okay, all the 16 bits are used. In mode 2 only 8 bits are used. Okay, in mode 2 only 8 bits are used. Okay, 8 bit यूज करने का मतलब क्या है, 8 bit यूज करने का मतलब क्या है, तो जब मैं मैक्सिमम वैल्यू कितना लोड कर सकता हूँ, अब 16 बिट रजिस्टर यूज कर रहा हूँ मैं, 16 बिट रजिस्टर यूज करने की वजह से मैं 65,535 लोड कर सकता हूँ. लेकिन अगर मैं सिर्फ 8 बिट यूज किया तो कितने बिट कितना मैक्सिमम वैल्यू डाल सकता हूँ इसके अंदर, ओनली 255. दिस इज द मैक्सिमम वैल्यू आई कैन load in your register because I am using only 8 bit of this 16 bit register. Okay, so I can load a maximum of 255. Okay, so I can generate a smaller timing delay in this, right? Are you getting the point? Suppose I use all the 16 bit. Okay, suppose I use all the 16 bit, what will happen in this, what will happen in this? Suppose initially I loaded 0 value in this. Okay, so what will happen from and I start the timer, what will happen, it will start to increment your register from 0 1 2 3 4 5 after every 1 microsecond. Okay, suppose I am using your timer in mode 1. In mode 1 what is happening, 16 bits I am using, no? So what happens, if I load 0 initially, what will happen, it will start to increment this 16 bit register 0 1 2 3 4 5 up to 65,535. It will increment because I am using all the 16 bit. Suppose if I use your timer in mode 2, that means the maximum value it can reach, the maximum value it can reach is 255. Okay, how you are getting is, it is 2 power, it is 2 power, it is 2 power 8. Okay, actually it is equal to 256. Okay, but you have to make it minus 1 because you are starting from 0. Okay, you're starting from 0. So this is the maximum value, your 8-bit value, this is the maximum 8-bit value it can reach. Okay, so what will happen initially, if I use only 8-bit, okay, if I set my timer in mode 2, that means only 8 bits can be used, only 8-bit of my microcontroller can be used. Okay, so now see this. Okay, for starting the timer, suppose initially I load a value of 0, a 0 in mode 2. Okay, in mode 2, now I'm using only 8 bits. Okay, so what your timer will do, it will start to increment your 8 16 your register. What will happen, it will start counting like this: 0 1 2 3 4 5, like this. So it can reach a maximum value of 255 only, not more than that. In 16-bit, what was happening, it was able to reach 65,535. Okay, but here in 8-bit mode, what it can do, it can go to a maximum value of 255 only, right? So here in 16-bit you can generate larger timing, right? It is natural because it can count up to 65,535, right? Into into 1 microsecond. This much delay you can generate in 16-bit, but in 8-bit only into 1 microsecond. Only this much delay you can generate in your 8-bit. Okay. Now in mode 3, what is happening is the lower and upper bytes of your 16-bit, they are working as a separate timers. Lower 8-bit is acting as a 8-bit timer, and upper 8-bit is also working as a separate 8-bit timer. So at a time, two 8-bit timers are running in mode 3. Okay, mode 0 में क्या हो रहा है, only 13-bit. मोड 1 में क्या हो रहा है, all 16 bits of your 16-bit register are used. In mode 2 only 8 bit are used, and in mode 3 actually two timers of 8 bit are working. Okay, because it is a 16-bit register, lower 8 bit one timer and upper 8 bit one time. Okay, so in mode 3 what is happening, two timers of 8 bit are working. Okay, there is one special thing about mode 2 that I want to tell you. There is one special thing, about mode 2 that I want to tell you. Okay, so what is that special thing? It has a auto reload function. Okay, what it has? It has a auto reload function. Auto reload function में क्या होता है, जैसे ही आपका वैल्यू, बिकॉज इट इज यूजिंग 8-bit, नो, आई इनिशियली सपोज आई लोडेड इन मोड टू आई लोडेड ए 0 वैल्यू. ओके, एंड आई स्टार्टेड द टाइमर. what will happen, it will start to increment this from 0 1 2 3 4 5 up to it will reach a maximum value of 255. okay, 255 होने के बाद क्या होता है, मैक्सिमम वैल्यू 255 जैसे ही ये रीच हो जाता है, ये ऑटो रीलोड फंक्शन क्या कर देता है, वापस से उसके अंदर 0 लोड कर देता है, ऑटो रीलोड. ओके, वापस से ऑटोमेटिक 0 लोड होता है ताकि वो साइकिल चलता रहे. अगेन एंड अगेन इट विल बी repeating from 0 1 2 it will reach 255. Because of the auto reload it will load again that 0 value. Okay, again it will start to count from 0 1 2 3 4 5 up to 255. So there is one speciality about mode 2. In mode 2 there is a auto reload is available. Okay, in mode 2 what is there, auto reload is available in your mode 2. But it is a 8-bit timer only. So a maximum of 255 microsecond can be generated. Okay. Anyone has any doubt in modes or working of the timer? They can ask the question, or I can move to the next slide. Yes, guys. Anyone is having doubt in this?
No, sir, no.
Okay, you guys understood the working how the timer is generating the and what are the different modes in which the timer works?
Yes, sir.
Okay. So now you can understand this slide. Okay, this is your TMOD register. It is of 8-bit. Okay, as I told you, there are two timers, timer 0 and timer 1. The lower 4 bits are used. The bits from 0 to 3, they are used for controlling the timer 0, and the bits from 4 to 7, they are used for controlling the timer 1. As you can see here, the bits 1 and 0 क्या है ये M1 और M0 है. M1 M0 मतलब 2 bits है, right? 2 bits मतलब you can use, okay, you can use them for selecting the modes. Okay, these bits M0 and M1, M0, it is better to use paint. ओके, तो क्या होता है, ये जो आपके बिट्स है M1 एंड M0, ये क्या करते हैं, आपके मोड को सेलेक्ट करने के लिए यूज किए जाते हैं. ठीक है, तो सपोज इफ यू वांट टू यूज योर टाइमर इन मोड 0, so what microcontroller will do, it will store a 0 and a 0 in place of M1 and M0. Suppose if your microcontroller wants to use the mode 1 of your timer, so what it will do, it will make this 0 and 1. Okay, if you want to make use of mode 3 of your timer, then it will the M1 and M0 are loaded with 1 and 0. Okay, and finally, if you want to use your timer in mode 3, what M1 and M0 are loaded with 1 and 1. So M0 and M1, both these bits are used in combination. Why they are used for? They are used for selecting the modes of your timer. जब ये 0 0 रहता है तो मोड 1, ओके, मोड 1 सेलेक्ट होता है, और जब ये 0 1 रहता है तो मोड, ओके, 0 0 रहता है तो मोड 0 सेलेक्ट होता है, 0 1 रहा तो मोड 1 सेलेक्ट होता है, और 1 0 रहा तो मोड 2 सेलेक्ट होता है, और 1 1 रहा तो मोड 3 सेलेक्ट होता है. That is how the 4 modes of your timer are selected. Okay, M1 and M0, they are used for selecting the modes of the timer. Okay, so here you can see in both the halves you can see, okay, in timer 0 as well as timer 1, in both the halves you can see there is, here also there is M1 and M0, here also there is M1 and M0. Okay, this this M1 and M0 is used for selecting the mode of timer 0, and this M1 and M0, they are used for selecting the modes of timer 1. Okay, now this bit 2 or bit 6, it is written as C by T bar. Okay, C by T bar. Your timer can also function as a counter. Okay, not only it can generate the timing signal, but also it can count the events also. Okay, in both modes. For example, a button is connected to your microcontroller. Okay, a button is connected. Okay, suppose a button is connected to your microcontroller. Okay, and you want to know how many times this button was pressed. Okay, how many time your this button was pressed, how many times this button was pressed. So what you can do is you can set this mode, this C by T bar into counter mode. Okay, so it will start to count. Okay, as you know, it uses the 16-bit register in the timer section I told you. So in timer what happens, once you start the timer, it will start to increment this 16-bit register. लेकिन काउंटर में क्या होता है कि जब भी बटन प्रेस होता है ना, तभी इंक्रीमेंट होता है ये रजिस्टर. दैट इज द डिफरेंस. ओके, in timer it is used for generating the timing. Okay, but if you set your tmod in this bit 2 in C by T bar as counter mode, it can count the number of events. Okay, if I press this button, once. Okay, if I press this button, this 16-bit register will show 1. If I press this button again 2 times, this 16-bit register will show 2. If I press this button 3 times, this 16-bit register will show 3. So this timer register of 16-bit, it can be used for both generating the times as well as for counting the events. Okay, so here you can see in bit 2, it is written as C by T bar. Okay, C by T bar. C by T bar का क्या मतलब होता है? काउंटर और टाइमर. ओके, काउंटर और टाइमर. सी बाई टी बार का मतलब क्या होता है? काउंटर और टाइमर. इफ यू इन बिट टू इन बिट टू इन बिट टू if you load a 1 if you load a 1, that 16-bit register will start to act as a counter. But if you load a 0 in that, it will start to act as a timer. Okay, so you can see C by T is there in both the halves. In timer 0 half it is also there, in the timer 1 half it is also there, it is there. Okay, it is there both, in the both section it is there. Okay, so बिट टू क्या करता है? बिट टू में अगर मैं 1 स्टोर कर दिया तो टाइमर 0 विल एक्ट एज ए काउंटर. ओके, लेकिन अगर मैं बिट टू में 0 स्टोर किया तो इट विल एक्ट एज ए टाइमर ओनली. ओके, सिमिलरली बिट 6 में अगर मैं 0 यूज स्टोर कर सॉरी अगर बिट 6 में अगर मैं 1 स्टोर कर दिया, इट विल स्टार्ट टू एक्ट एज ए काउंटर. और if bit 6 में अगर मैं 0 स्टोर कर दिया, it will start to act as a normal timer. ओके, देखो ध्यान से देखो, it is C by T bar. ओके, C by T bar. T bar का क्या होता है? एक्टिव लो होता है. ठीक है, T bar क्या होता है? एक्टिव लो होता है. जब 0 स्टोर करते हैं ना, तभी वो सिग्नल एक्टिव रहता है. T bar मतलब टाइमर के लिए यूज होता है. T bar is for timer and C is for काउंटर. ओके, तो C क्या है? एक्टिव हाई है, और T क्या है? एक्टिव लो है. इसलिए C में अगर मैं बिट 6 में अगर मैं 1 स्टोर कर दिया, देन इट विल एक्ट एज ए काउंटर. लेकिन अगर मैं बिट 6 में 0 स्टोर कर दिया, देन इट विल एक्ट एज ए टाइमर. Okay, so the gate bit, the last bit is gate, that is also in both the halves. So it is just used for controlling. If you want to enable or disable your timer, that you can use that gate bit. Okay, if you store a 1, it will work, otherwise the timer will work, if otherwise the timer will not work. So did you understand the meaning of this C by T and this TMOD register? If anyone has doubt in TMOD register, they can ask the doubt, or I can move to the next slide. Anyone has doubt in this TMOD register?
No, sir.
Okay, then I will move to the next slide. Okay, the next important register that you are going to study is timer control register. Okay, timer control register. Timer control register क्या किस लिए यूज होता है? It is for controlling the timer. Okay, लास्ट सेक्शन में आप टू टाइमर्स पढ़े थे, टाइमर 0 एंड टाइमर 1. तो ये टाइमर कंट्रोल रजिस्टर क्या करता है? टाइमर वो टाइमर्स को कंट्रोल करने के लिए ये टीकॉन को यूज करते हैं. ओके, so TCON, what are the bits in TCON? As you can say, it is also an 8-bit register from 0 to 7. The different bits in this register are IT0. Okay, the different bits in this register are IT0, IE0, IT1, IE1, TR0, TF0, TR1 and TF1. Okay, so you can see in this. Okay, on some bits 1 is written and on some bits a 0 is written. Okay, here TF1 is there and here TF0 is there and TR1 is there and TR0 is there. 1 means it is used for controlling the timer 1 and 0 means it is used for controlling the timer 0. Okay, we will see the function of each bit. Okay, each bit. So first of all, let me explain you what is the function of TR. Okay, TR, timer run. Okay, what is the function of TR bit? TR bit किस लिए यूज होता है? It is used for running the timer. As I told you, it uses this register. तो क्या होता है? सबसे पहले उसके अंदर जो भी आपको वैल्यू स्टोर करना होता है, जैसे कि मैं आपको लास्ट टाइम बता था 65,500 एंड this suppose 31 you loaded. Okay, तो क्या होता है? वंस यू लोड दिस वैल्यू 65,531, टाइमर को स्टार्ट करना पड़ता है. ठीक है, टाइमर को स्टार्ट करने के बाद ही ये रजिस्टर का वैल्यू इंक्रीमेंट होना शुरू होता है. तो तो टाइमर को स्टार्ट करने के लिए क्या करना पड़ता है? माइक्रो कंट्रोलर को TR1 में, अगर टाइमर 1 है, अगर आप टाइमर 1 को स्टार्ट करना चाहते हैं तो TR1 में 1 को स्टोर करना. ठीक है, if in TR bit a 1 is stored. Okay, TR bit में अगर 1 स्टोर कर दिए आप तो आपका टाइमर रन. ओके, टाइमर रन होना शुरू होता है. दैट मीन्स योर टाइमर स्टार्ट्स. ओके, दैट टाइमर स्टार्ट होने का मतलब क्या है? जो भी आप वैल्यू 16-bit रजिस्टर में स्टोर किया है दैट विल स्टार्ट टू इंक्रीमेंट. दैट इज व्हाट इट मीन्स आफ्टर एवरी 1 माइक्रोसेकंड. ओके, तो बेसिकली TR1 का मतलब क्या है? TR, TR stands for timer run. Okay, TR stands for timer run. This bit, TR bit, is used for nothing but for starting the timer or for running the timer. If the microcontroller stores a 1 in TR, your timer starts. So you can see there are two TR, TR1 भी है और TR0 भी है. TR1 टाइमर 1 को स्टार्ट करने के लिए यूज होता है और TR0 टाइमर 0 को स्टार्ट करने के लिए हो सकता है या बोल सकते हैं रन करने के लिए यूज होता है. ओके, you can say that TR means timer run. Okay, next TF. Okay, TF bit is there. Another bit is TF is there. Another bit is TF. TF stands for timer overflow. Okay, timer overflow. TR stands for timer overflow. जैसे कि ये रजिस्टर में मैं बोला था, जो भी वैल्यू आप स्टोर करते हैं, जो भी वैल्यू आप स्टोर करते हैं, दैट वैल्यू इन दैट रजिस्टर starts to increment once the timer starts. Our maximum value what it can reach? It can reach 65,500 35. Okay, this is the maximum value it can reach. Okay, 65,535. This is the maximum value your timer register can give. Once this reaches the maximum value, and then where your microcontroller starts to increment again. Okay, it starts to increment again. It will be greater than 65,535. No, it will try to make it 65,536, but your register can hold a maximum value of 65,535 only, right? तो दैट मीन्स टी एफ का मतलब क्या होता है? टाइमर ओवरफ्लो। टाइमर ओवर, यहाँ पे कंटेंट का ओवरफ्लो हो रहा है ना। योर रजिस्टर कैन स्टोर 65,535, बट once it reaches this 35 value, your timer tries to increment it again and tries to make it 65,536, but that is not possible. That means it has reached the maximum value. Okay, your timer has reached the maximum value. So, whenever the timer reaches the maximum value, the time TF flags becomes 1. The timer overflow flag becomes 1. Okay. Once this becomes 1, okay. Once your TF flag becomes 1, your microcontroller comes to know, that whatever time was set, it has reached its maximum value. For example, say in this case you loaded 65,531. You started the timer, it reached the 65,535. After reaching that maximum value, TF flag becomes 1. Okay, TF flag become 1. That is how your microcontroller comes to know that the maximum value of your register has reached. That means that time duration what you set, no, that is reached. So based on that, your timer can perform whatever the action is needed. Okay, so that is TF. Okay, TF is timer overflow. Okay, when it reaches the maximum value of 65,535, TF will become 1. Okay, that is how once your TF becomes 1, your microcontroller comes to know that maximum value is reached. Okay, next is IE. Okay, next is IE. You can see the bit 3 is labeled as IE. Okay, the bit 3 is labeled as IE. IE is nothing but interrupt edge. Okay, interrupt edge. What is the time? 11:22. Okay, IE is nothing but interrupt edge. Your microcontroller, your 8051 microcontroller has two external interrupts. Okay, two external interrupts. Okay, that is T1 is for timer 1 and T0 is for timer 0. Okay, T1 is for timer 1 and T0 is for timer 0. So whenever an interrupt comes at T1, whenever an interrupts come at T1, IE, IE is made 1. Okay, interrupt, it is like interrupt edge is detected. Suppose at T1 you detect a like this. Okay, a high. Okay, at T1, if you detect a high signal at T1, okay, if you detect a high signal at T1, your IE will become 1. Okay, once your IE becomes 1, your microcontroller comes to know that someone is some external device, some external device, some external device that is connected to your microcontroller wants the attention. Some external device connected to your microcontroller externally wants the attention. Okay, so at that time IE becomes 1. Okay, I is nothing but interrupt edge. Okay, interrupt edge. Okay, whenever an external device interrupts this microcontroller through T1, IE becomes 1. Okay, once that IE becomes 1, the microcontroller stops whatever work it was doing. It will go to that device. It will perform whatever the request asked by the externally connected device. Again, IE becomes 0. Okay, after performing the request of the externally connected device, IE is made again 0. Okay, so that is called as whatever the request is performed, whatever the request is asked by the externally connected device, when the microcontroller performs that action, or that request, it is called as serving the externally connected device. Okay, sir. So microcontroller, once the device interrupts, okay, at T1 it interrupts, IE becomes 1, the microcontroller stops whatever work it was doing, then it will serve the externally connected device, again IE will be made 0. Okay, because there are two interrupts, T1 and T0. Okay, T1 and T0. So T1 is for IE1 and T0 is for IE0. Okay, are you getting the difference? So that is what it is used for. Next, IT1 and IT0. Okay, IT1 and IT0 का मतलब क्या है? It is very simple. IT1 क्या है? अगर आप इंटरप्ट को फॉलिंग एज में, अगर आपको इंटरप्ट को मतलब कि आप, इफ यू वांट द माइक्रो कंट्रोलर टू रिकॉग्नाइज द इंटरप्ट व्हेन देयर इज अ फॉलिंग एज सिग्नल. ओके, दैट मीन्स दिस इज कॉल्ड एज फॉलिंग एज. Okay, this is called as falling edge of your signal. This is called as from here. This is high. Now your signal at the interrupt pin is going low. Whenever the signal from goes from high to low, no, that is called as falling edge. Okay. So if you want to recognize interrupt when there is a falling edge at T1 or T0 pin, whenever there is a falling edge at T0 or T1, then you make IT0 or IT1 as 1. Okay, if you make IT0 and IT1 as 1, what your microcontroller will do? It will recognize an interrupt when there is a falling edge. When there is a falling edge, this is called as falling edge. Okay, whenever your microcontroller sees a falling edge at your pin interrupt pin T1 or T0, at that time it is recognized as an interrupt. Okay, you might be knowing there are two edges like this. This is rising edge because your signal is going from 0 to high, and another is falling edge. This is from here the signal is going from high to low. So if you want to at pins interrupt pins, if you want to recognize the interrupt whenever there is a falling edge, then you can make IT1 or IT0 as 1. If you store in place of IT0 IT1, your microcontroller will recognize interrupt by falling edge. So what the external device should send, if this is your microcontroller and there is an externally connected device to this, this should send a falling edge signal. This should send a falling edge signal to the microcontroller for interrupting the microcontroller. That is what your IT1 and IT not pins are, IT not bits are used doing. So, anyone has any doubt in this TCON register? They can ask the question if you are having any doubt. Yes, guys, please ask the question. Or shall I move to the next slide? Guys,
Yes, sir.
you have any doubt
Yes,
in TCON register?
no, sir, no.
Okay, you understood the meaning of TF, TR, interrupt enable and IT?
Yes, sir. TF, overflow, TR, timer. Yes, sir.
Okay. Okay. Interrupt enable. Okay, the next register, that SFR, the next register or the SFR that you are going to study is interrupt enable. Interrupt enable. This is very simple. Okay, from 0, this is also an 8-bit register. Okay, this is also an 8-bit register. As you can see from the name itself, interrupt enable का मतलब क्या होता है? It enables the interrupt. Okay, unless you enable an interrupt, it can any device cannot interrupt the microcontroller. Okay, no device can interrupt the microcontroller unless and until interrupts are enabled. So there are, as you know, there are different kinds of interrupts that are available in your microcontroller. E, okay, there is a serial interrupt is also there. There is external interrupt T1 is also there, and another interrupt is T0 is also there. Okay, T0 interrupt is also is there, that is generated with the timers, and there are external interrupts. EX interrupt is also there. Okay, EX interrupt, EX1 and EX2. These are the different interrupts that are available on the microcontroller. This T1 interrupt and T0 interrupt, they are generated by the timers. Okay, they are generated by the timers, and this interrupts EX1 and EX0, they are generated by the externally connected devices. Okay, so these are the different interrupts that are available in your microcontroller. So here you can see ES is there, ES is there, ET1 is there, EX external interrupt there, ET0 it is timer 0 interrupt is there, and EX0 is externally connected 0 interrupt. EX stand for external interrupt. ET stands for timer interrupt. So E, okay, E is enable as ES. ES is enable serial port interrupt. Okay, serial port interrupt. ES is enable serial port interrupt. सीरियल पोर्ट इंटरप्ट में क्या होता है? सब एक एक्सटर्नली कनेक्टेड डिवाइस है, ठीक है, टू योर माइक्रो कंट्रोलर, एंड दैट माइक्रो डिवाइस वांट टू सेंड द सीरियल डेटा. ओके, सीरियल डेटा टू योर माइक्रो कंट्रोलर. तो सीरियल डेटा सेंड करने से पहले क्या करना पड़ता है? उसको माइक्रो कंट्रोलर को इंटरप्ट करना पड़ेगा, राइट, दैट आई वांट टू सेंड द सीरियल डेटा. माइक्रो कंट्रोलर कोई दूसरा फंक्शन भी परफॉर्म कर सकता है, राइट. तो लेकिन अगर बीच में कोई डिवाइस इंटरप्ट कर रहा है माइक्रो कंट्रोलर को कि मैं सीरियल डेटा भेजना चाहता हूँ, आई वांट टू सेंड द सीरियल डेटा, एट दैट टाइम क्या करेगा? वो सीरियल इंटरप्ट सेंड करेगा. तो वो सीरियल इंटरप्ट सेंड तभी कर सकता है जब ई एस इक्वल टू 1 है. ई एस इक्वल टू 1 अगर रहा तो ही वो सीरियल इंटरप्ट सेंड कर सकता है. दैट मीन्स यू आर एनेबलिंग द सीरियल इंटरप्ट. फॉर एनेबलिंग द सीरियल इंटरप्ट you have to make ES, okay, ES as 1. नेक्स्ट ET1. ET1 क्या होता है? टाइमर 1 इंटरप्ट को, टाइमर 1 इंटरप्ट को सेट करता है. ओके, टाइमर 1. ओके, एट पिन टाइमर 1 एनी डिवाइस कैन send the interrupt the microcontroller, or the microcontroller can also send the interrupt the device. Okay, but the speciality about this ET1 and ET0 is they are generated by the timers only. Okay, they are generated by the timers. After a certain event has happened or certain time duration has happened, these kind of this ET1 and ET0 interrupts are generated by the microcontroller. Or maybe for example, if externally suppose you connect a button to your microcontroller. Okay, suppose you connect a button to your microcontroller at pin T1 and T0. Okay, so what you want to do, suppose if you press the button, then you want to start the timer. Okay, at that time this T1 and T0 are used. So once the user presses that button connected to this T1, that interrupt is detected at ET. Okay, T1, and the timer starts. And the timer starts. What you want to do? Once suppose a button, externally connected button is connected at T1 and T0. Once that button is pressed, you want to start the timer. Okay, at that time, for that requirement, what you can do? You can connect the button to your T1 and T0 pin. Okay, that is also a way for interrupting the microcontroller. Or once a certain time events reaches, okay, at that time also T1 and T0 interrupts are generated by the microcontroller. For generating the timer interrupts, okay, for generating the timer interrupts, T1 and T0 bits must become 1. Otherwise, the T1 and T0 bits will not be able to interrupt the microcontroller. Okay, suppose I set a timer for 4 microseconds. Say, okay. Suppose I set a timer for 4 microseconds. Okay. Once that 4 microsecond reaches, the microcontroller must be alerted. No, that 4 microsecond time has reached. Okay. How they will do? They will do through timer interrupts. Okay. Timer interrupt. The timers will interrupt the microcontroller and tell that 4 microsecond has reached. So based on that, you can perform the whatever function you want to. So there are two timers, ET1 and ET0. Okay, so they can interrupt the externally connect. They can interrupt the microcontroller. Okay, EX1 and EX0. These are also interrupts. Okay, these are also interrupts. They are for externally connected device. They are for externally connected devices. Two devices that are connected externally, they are connected externally, they can interrupt the microcontroller. They can interrupt the microcontroller. So if you want to enable the interrupt for the externally connected devices, you must make EX pin as 1. Okay. So basically, briefly what I can tell you is interrupt enable is used for enabling the interrupts. Unless you make the bit 1, no device or timer can interrupt the microcontroller. If you want to enable the EX0, you can make that one. Similarly, if you make ET01, then timer 0 will be able to interrupt. If you make EX1, then externally connected device can interrupt your microcontroller. Then ET1 means timer 1 can interrupt your microcontroller. ES is for serial. If suppose any externally connected device wants to send the serial data to your microcontroller, at that time ES1 will be enabled. Okay. So this is interrupt enable is nothing for, but it is used for enabling the interrupts. Unless and until a 1 is stored, unless and until a 1 is stored in place of En, Et1, Ex1, Et0, Ex0, no interrupt will work. 1 must be stored. Okay, these bit must be set. That is called as enabling the interrupt. Okay, the last pin, the seventh pin, it is EA pin. Okay, EA pin. It is used for disabling the interrupts. Once you make this EA pin as 1, nothing, neither timer nor externally connected devices can interrupt the microcontroller. It will disable all the externally connected devices. Okay, so interrupt enable. This is what about your interrupt enable register is. So you guys understood this, or shall I explain it once again?
सर एक डाउट था सर।
हाँ बोलिए।
सर ये ET1 EX1 जो पहले से ही एनेबल है, ये लोग पहले से ही एनेबल रहते सर, नहीं फिर से करना पड़ता है इनको?
नहीं नहीं, एनेबल करना पड़ेगा आपको। जैसे ही आपका माइक्रो कंट्रोलर स्टार्ट होता है, रीसेट करते हैं ना, तब ये सब जीरो रहता
अच्छा, बस खाली इंडिकेशन है ET1 EX1, मगर ये लोग डिसेबल ही रहते हैं।
है। यस, डिसेबल रहते हैं ये लोग। जब तक कि आप इनकी प्लेस पे वन स्टोर नहीं किए, तब तक वो लोग डिसेबल ही रहते हैं। अगर आपको एक्सटर्नली, सपोज कोई एक्सटर्नली कनेक्टेड डिवाइस है, आपको इंटरप्ट जनरेट करना है, वो डिवाइस वांट्स टू इंटरप्ट दी माइक्रो कंट्रोलर, देन EX0 must be made one.
ओके सर।
And otherwise the
And
microcontroller
similar to EX1 and ET1.
EX1 externally connected interrupts two है, okay, EX0 और EX1 दो डिवाइस कैन इंटरप्ट योर 8051 microcontroller, okay, EX0 एंड EX1, okay। ET0 ET1 क्या है, ये टाइमर के लिए है। टू टाइमर्स है ना आपके माइक्रो कंट्रोलर में। तो
यस सर, यस।
हाँ, तो वो टाइमर क्या कर सकते हैं, वो भी इंटरप्ट जनरेट कर सकते हैं, लेकिन जब तक यहाँ पे वन स्टोर नहीं किए, तब तक वो टाइमर भी इंटरप्ट नहीं कर सकते माइक्रो कंट्रोलर।
ओके सर, समझ
ये मतलब सीरियल डेटा, सीरियल डेटा, कोई डिवाइस है, एक्सटर्नली कनेक्टेड डिवाइस है, वो सीरियल डेटा भेजना चाहता है आपके माइक्रो कंट्रोलर को, तो वो भी इंटरप्ट करना पड़ेगा ना पहले कि आई वांट टू सेंड द सीरियल डेटा। तो वो इंटरप्ट करने के लिए ईएस को वन रहना जरूरी। दैट इज कॉल्ड बेसिकली एनेबलिंग द इंटरप्ट।
गया। ओके सर।
ओके, ईए पिन क्या रहता है, ईए पिन में अगर आप वन स्टोर कर दिए तो कोई भी डिवाइस या टाइमर इंटरप्ट नहीं कर सकता, इट विल डिसेबल ऑल द इंटरप्ट्स, दैट्स इट।
ओके सर, थैंक
Okay, guys, we will continue in the next class. Thank you.
यू। ओके सर।
Thank you, sir.